So again, for today, we're going to be going over the velocity time graph. And these are the things that uh, we can get from the velocity time graph. The slope is now the average acceleration. So the unit for that matter is that, if you can see the slope, if you have velocity against time graph, that would be delta y over delta x. But in a velocity time graph, the y pertains to velocity. So therefore, that would be delta v. Then the x pertains to time. So that would be delta t. So if you can see the units there, the units will give you meter per second per uh, second. So if you're going to combine the two or simplify the two, the unit becomes meters per second squared. So which is somehow consistent with the unit of acceleration. So this is the unit of acceleration. The unit of acceleration is meters per second squared. So that means that the acceleration denotes the slope. So that's the significance of the slope in a velocity time graph, as well as the area under your graph. It gives you the displacement. So the area of the velocity time graph is just the displacement. And again, you can verify that one with a unit that it can create. If you're multiplying velocity again from this example here, you have a rectangular type of figure that is created by this graph here. So is it not that the area of a rectangle is just the length and the height, or the base times the height? So the base pertains to time, and the height pertains to velocity. So therefore, you have meters per second times second. So if you can see, that gives you the unit of meter. So which is the unit of displacement. Okay. So again, we went over this particular example here. It's just a straight line graph of the velocity time. And if you can see, in this particular case, the velocity is constant. So the slope is equal to 0 because you don't have any change in y, or in this case, again, the velocity. The y-axis to velocity. Delta v in this case is equal to 0. So if you have a straight line graph, again, that is just denotes delta v is equal to 0. There's no change. There's a difference with you have a particular velocity and there's no change in velocity. Okay, so that's a common mistake usually made by students, because they try to relate change in velocity to just velocity. Because in some cases they think that if delta v is equal to 0, the object is not moving. Actually, it can be moving, although in some cases it is not moving, because if the object is at rest, delta v there is also equal to 0. But just try to make sure that you somehow clearly have an understanding on the difference between delta v and just talking about the velocity of the object. Because by definition, if you can see here, from the slope itself, acceleration is the change in velocity over time. So there must be a change in velocity so that the acceleration is not equal to 0. And again, we're talking about the velocity time graphs, and you have three cases here. Positive acceleration if you have a positive slope. So this is positive slope. So automatically, if you can create a straight line that the slope is positive, that means that the acceleration is positive in the particular case. And then negative acceleration means negative slope. Well, if you can see, it's slanting in the opposite direction. And zero acceleration, that would be zero slope. Again, zero slope pertains to delta v is equal to 0. Remember that it is undefined if you have delta t is equal to 0. That's undefined because you cannot have a 0 denominator. Okay. So just try to remember, don't confuse yourself, the direction of motion of your object, because you might be thinking that a positive acceleration always pertains to positive direction, but it's kind of different, because later on when we talk about forces, the direction of your acceleration is not dependent on the motion of the object, but dependent on the net force being exerted on an object. Okay, so let's take this example number 3 here. Sketch a velocity time graph that shows an object with negative velocity and positive acceleration. So how can we sketch a graph that has a positive acceleration but negative velocity? So I'm just gonna create my coordinate system. So always this is my time. This is 0. And then, well, if this is north, so that means that I make this one as my positive direction. So anything at the bottom is south, or we assign it as a negative direction. Okay. So this would be my velocity. The unit is meters per second. And again, this is velocity versus time. So how can I have negative velocity but positive acceleration? Well, let's try to go back on what we know about negative velocity. So is it not that in the previous discussion, a negative velocity pertains that it's moving in the negative direction? Or that means that wherever we assigned as a negative direction, so that would be the direction of the object. It's either, again, in our case, we use north as positive, so we assign positive for north or negative for south, since we try to, again, just the opposite of north is, since the opposite of north is south, so therefore south is the negative direction. So that means that this particular object should be moving in the south direction. However, the acceleration should be positive, okay? So based on the discussion that we have here, when we try to create different graphs, is it that the positive acceleration pertains to positive slope, okay? So that means that negative velocity pertains to negative direction, and positive acceleration pertains to a positive slope in our velocity time graph. So if I'm going to create such graph, is it not that it should be somewhere here? Okay? Because if you can see, that's a positive slope. So this one here is a positive slope. This has a positive slope. However, is it not that all of this part here, this is your negative direction, that's south. Okay? So if you can see everything, any values below 0 here pertains to negative direction, or that would be moving south, because I set again north as my positive direction. However, if you can see here, this is positive slope. Okay? So since the slope is positive, it also follows that the acceleration is positive. So if you can see, doesn't necessarily mean that if the object, again, in this case, the object is moving in the south direction. So that would be moving in the south direction. However, the slope is directed to the north. Okay? Because positive means, again, we use positive as our direction for north. So in this case, the acceleration in the opposite is in the opposite direction with your negative velocity. And this is an example of, let's say, for example, well, a common example is that if you have a toy car, you try to move it. When you try to release the object, is it not that eventually it will stop? And do you know why it stops? Anyone? Anyone? I have a toy car. I try to push it, but once it leaves my hand, eventually it will stop, right? It will not move forever. Why?
Is it because of resistance?
Resistance, yeah. And specifically, that resistance is we called as, anyone?
Friction.
Yeah, that's friction. So you have friction. And in that particular case, if, let's say, even though I'm trying to move my car in the south direction, okay, in the particular case, so it's moving south. So the velocity there is negative because it's moving south. However, is it not that friction, what you have learned about friction, friction always opposes the motion, or its direction is always in the opposite direction of motion. So therefore, in the particular case, friction is to the north. And that's the reason why the acceleration is north. It's not dependent on the motion of the object. It's actually the direction of acceleration is dependent on the net force acting on an object. But we will have a clear understanding about that when we talk about Newton's laws of motion. But for now, that's the particular case. If you can see, uh, again, the negative velocity doesn't necessarily mean that the value is small. That means that you cannot say negative 1 meters per second has a greater velocity compared to negative 2 meters per second. Okay? You might be thinking about, well, you're learning about integers, right? Negative. However, we just use the negative sign and positive sign here to denote our direction. Okay? But the magnitude, again, it's coming from the 1 meters per second and 2 meters per second. So that means that negative 1 meter per second does not have a greater magnitude compared to negative 2 meters per second. The negative signs there only indicates that they are moving in the south direction, well, or west. Okay? Because again, we just use the negative or positive sign to indicate our direction. And that is for the simplicity of our algebra, okay, for our computation. So in this particular case, you can actually think of this object as slowing down. So this object is slowing down because again, the magnitude is now close to zero, okay? However, it's slowing down. So this is just an example that I've shown or mentioned earlier. So again, common mistakes by students in this, when they try to analyze velocity time graph is that, yeah, they're thinking that the velocity, positive or positive velocity also means positive acceleration. Again, they have different meanings, okay?